We want our pen displays to be as accurate as possible when we are drawing. Accuracy means the visual agreement between the tip of the pen and where the operating system pointer is. They should be pointing at the same exact pixel. Pen tracking is what I call the ability of the tablet to sense the location of the pen. A perfect pen display would have perfect pen tracking, and there would be a visual agreement between pen and pointer under all conditions. At any location on the display, at any tilt of the pen, no matter how fast the pen is moving, and even if the pen is hovering and not directly touching the tablet. But there's no such thing as a perfect pen display. They all have some inaccuracy, some visual disagreement. There are two components to that visual disagreement. First, there are real inaccuracies with the EMR sensor. This means that the tablet will not correctly identify the position of the pen, and the pointer will be drawn in the wrong location. Second, there is an apparent inaccuracy. This is due to parallax, a visual effect that has nothing to do with the EMR sensor. It has to do with the glass on the tablet and viewing angles. This is a typical pen display. Instead of focusing on the entire display, I will take a single row of pixels going across the display, and I will draw that as a simplified cross-section of the pen display. You will see a lot of this diagram in the video. Note that this is a laminated pen display. I will talk more about what lamination means later. There are 3 layers to this pen display. The EMR sensor at the bottom is a gray layer with a yellow stripe in the middle. The yellow stripe represents the wires of an EMR sensor. If you were to look at the EMR sensor top down, you would see that the wires form a kind of grid. This grid sends power to the pen and then detects the resulting electromagnetic signal sent from the pen. The display panel is the middle layer. I've represented the display panel here with just 15 pixels. There are 5 light gray pixels on the left, 5 light gray pixels on the right, and in the middle, there are 5 pixels that vary in color from light green to purple. The dark gray sections to the left and right of the pixels represent some plastic. The plastic is here simply to support the glass layer above. Did you notice that the EMR sensor wires are wider than the display panel? This is deliberate and beneficial. You'll see why later. The top layer is a sheet of glass. The glass protects the panel and has other benefits. For example, it could have an etched surface. The etched surface helps avoid glare, and the etching also provides a nice grip for the pen, so that drawing on the glass does not feel so slippery. With an EMR tablet, remember that the EMR sensor does not detect the tip of the pen. The sensor detects an inductor coil that is deeper inside the pen. Frankly, it's kind of amazing that these drawing tablets work so well and with so much precision because there is quite a bit of distance between the sensor and the inductor coil. Now we will discuss real inaccuracies. That is, the inaccuracies that come from the EMR sensor. Because I do not want to talk about parallax now, I'm going to remove the source of the parallax in the diagram, which is the glass sheet. So any visual disagreements you see now are due to inaccuracies in the EMR sensor and not parallax. We need an easy way to indicate where the pointer is. I'll do that by highlighting a pixel in red if that is the location the tablet thinks the pen is pointing at. Let's start with a pen tablet that has perfect pen tracking. This means that the tip of the pen and the red pixel will always visually agree. Even if I move the pen, the red pixel will follow exactly. The cross-section diagram is useful, but we also need to understand what our eyes would see. To make that more clear, I'll draw an eye somewhere and draw a line of sight from the eye through the tip of the pen and to the top of the display panel. In the upper left corner, a diagram indicates what it would look like from the eye's perspective. And in this case, there is a clear visual agreement. The pen and the pointer are at the same pixel. Even if I change the location of the eye so that there is a different line of sight, both eyes will still see the same thing. The tip of the pen and the pointer are at the same pixel. Again, there is no parallax in this case because I've removed the glass sheet. So this agreement in positions will always be true no matter what position your eyes are in. Of course, there is no perfect pen display with perfect pen tracking. Real-world pen displays have tracking inaccuracies. In the next set of diagrams, we'll show you the visual disagreements that come from some of those tracking inaccuracies. And again, no parallax will be involved in these cases. Here is a simple example of a visual disagreement. The tip of the pen is pointing at 1 pixel, but the tablet thinks the pen is pointing slightly to the right. So there is a little bit of displacement between the tip of the pen and the pointer, and that displacement will persist even as the pen moves. The displacement creates some odd situations at the edges of the display. Sometimes the pen is not pointing at a pixel, but the tablet thinks it is. And sometimes the pen is pointing at a pixel, but the tablet thinks it is not pointing to a pixel. This is a very, very simple example of a real inaccuracy, and you can see it in the cross-section. And because there is no parallax, your eyes will consistently and correctly see the inaccuracy. This simple example featured a pen and pointer disagreeing always by 1 pixel. But in the real world, tablets can have all sorts of inaccuracies. The displacement doesn't have to be 1 pixel. It could be quite large, like 50 pixels. The displacement may not be constant. Instead of always being 1 pixel, it might be 10 pixels in the upper right-hand side of the tablet and 5 pixels in the lower left-hand side of the tablet. The displacement might also be affected by the speed of the pen. That's called lag. I'm not going to talk about lag in this video. It's a great topic, but I'll do a separate video on it. In this video, I'm going to focus on a pen that is stationary or moving slow enough that lag is not an issue. This is a video of me using a Wacom 1 pen display, and you can see there's quite a dramatic inaccuracy. I want to be clear that when I got this tablet, it was perfectly accurate. However, I have deliberately configured it to be inaccurate just so I can demonstrate it for you. But sometimes people do get a new tablet and it comes out of the box with this level of inaccuracy. If your pen display is exhibiting an inaccuracy like this, then check if your pen display has a pen calibration feature. This isn't a color calibration, this is pen calibration. The pen calibration will help get the tip and the pointer to be in good agreement. For the Wacom 1, you can find the calibration feature in its driver. Doing the calibration is very simple. Once you click Calibrate, it will just ask you to click on some more points. That will take only a few seconds. Here's what my Wacom 1 pen display looks like after I did the calibration to fix it. As you can see, there is very good agreement between the tip of the pen and the pointer. You may notice that as I move the pen, there is some inaccuracy due to the pen movement. This is lag. Again, I will cover lag in a separate video. The vast majority of you will never experience this kind of very dramatic inaccuracy. If you do see the problem, then check if your tablet has a pen calibration feature. If the calibration isn't working, or you don't have a calibration feature, and other basic troubleshooting isn't helping, then contact the support team from your manufacturer. Let's look at another kind of inaccuracy. To understand this inaccuracy, let's take a look at an overhead view of a pen display. The blue rectangle represents the display panel. I'm going to add some stripes to help explain what's going on. I will add green stripes wherever the accuracy is very good, and I will add red stripes wherever the accuracy is bad. All pen displays have this kind of arrangement where the accuracy is pretty good for the vast majority of the display surface, but as it gets close to the edge, and especially at the corners, you will start to see some sudden changes in accuracy. Now this diagram is not to scale, and it does exaggerate the size of the red region. In reality, it's very small, just a few millimeters. The inaccuracy can manifest in several ways. As your pen gets closer to the edge or corner, then the pointer might kind of be repelled by the edge or corner. As your pen gets closer to the edge or corner, your pointer might be attracted to and accelerate toward the edge or corner. And then sometimes, as your pen approaches the edge or corner, you will see that there's a kind of noise or jitteriness or unsteadiness of the pointer. This is an example of me using a Huion Canvas 22 Plus. Now remember, I love using this pen display. I use it all the time with my work computer for whiteboarding during online meetings. But as you see, when I take the pen and move it toward the right edge, the pointer suddenly accelerates toward the edge faster than the pen. Based upon the pen displays I have, this model seems to exhibit a large amount of corner inaccuracy. Even then, it does not really bother me, because my pen is really never in those positions at the corner and not at the extreme edges either. And I am certainly not drawing there. Sometimes you can find that a manufacturer has published specific numbers for their accuracy at both the center and the corners. By researching through the manufacturers' websites for their tablet models, I have collected some common accuracy numbers in this table. I have a Huion pen display, a Canvas Pro 24 4K. Huion says the accuracy of this tablet is plus minus 0.3 millimeters in the center and plus minus 3 millimeters in the corner. Honestly, I think these numbers overstate the inaccuracy. And in my personal experience, with the model I have, the corner accuracy is better than they say. I also have a Wacom Cintiq Pro 27. Based on my experience with pen displays, the Wacom Cintiq Pro 27 has the best corner accuracy I've seen. Now, I don't have any numbers published by Wacom about their accuracy, but if someone told me their accuracy was in the lower part of this table, or even at the very bottom row, I would certainly believe them. Now remember, as with any specifications that come from manufacturers, they never tell us how they're measuring these numbers, or how they test their models to verify these numbers are accurate for their models. And I have no scientific way of validating the numbers myself, so all I can talk about is my subjective experience. Why do we see inaccuracy at the edges and in the corners? Let's again start with a top-down view of a pen display. I'll remove the glass layer and the display panel. Now we are just left with the bottommost layer, which is the EMR sensor and that grid of wires inside of it. Notice there are not like thousands of wires, just a few tens going horizontally and vertically. You know that the grid is sensing an electromagnetic signal given by the pen, and obviously only some of the wires are detecting the signal. And the tablet is looking at all the wires that detect the pen and combining that data to arrive at some precise location for the pen. So if the wires are doing the detection, it stands to reason that if there are fewer wires doing the detection, then accuracy will suffer. So let's move the pen to the right edge. It's very clear. There are fewer wires to help locate the pen. And especially in the corner, there are fewer wires still to help locate the pen. So in summary, I think this is what's causing the inaccuracy that we see at the edges and especially in the corners. Earlier in the video, I mentioned that the EMR sensor is actually larger than the display panel. And now you can get an intuition about why that is. Because that extra size of the EMR sensor helps locate the pen more precisely at the edges and corners. Of course, even with that extra sensor area, it still looks like pen displays aren't quite as precise in the corners and edges as they are in the middle of the display. This is something I hope manufacturers of drawing tablets will improve in the future. Diagonal wobble is another very common inaccuracy that is due to the EMR sensor. I will cover diagonal wobble in detail in another video, but I'll give you the basics now. What I mean by wobble here is that there's a periodic oscillation of the pointer away and towards the tip of the pen. If you slowly draw a line, perfectly horizontally or vertically, you won't see any wobble. But as the angle of the line shifts from purely vertical or horizontal, the wobble will start to creep in. And the wobble is at its greatest at 45 degrees. The wobble is present in every kind of drawing tablet, whether they are pen tablets or pen displays. The wobble is present in all sizes of drawing tablets and at all price ranges. In fact, the wobble is not even limited to EMR drawing tablets. The wobble is apparent even in devices that don't use EMR. For example, an Apple iPad or a Microsoft Surface. One of the frustrating things about the wobble is it happens even if you're going slow and trying to be precise. You should know that the wobble is occurring all the time, and not just when you're drawing a straight line. I'm using straight lines in the video only because the wobble is more apparent that way. If you look across many different drawing tablets, you will see a wide variation in how much wobble is present. Pen tablets exhibit less wobble in general than pen displays. I tested the wobble of several drawing tablets. My procedure was pretty simple. I used a plastic ruler to draw a 10 centimeter line at a rate of about 2 or 3 centimeters per second, which is pretty slow, and that line was tilted at around 45 degrees. Here's a Wacom Intuos Pro Large, model number PTH 860. This has the least diagonal wobble of any tablet I've ever seen. This is truly excellent. There is only the most microscopic of wobbles. And it's so tiny, I can't even be sure that it wasn't my hand that caused it. This is a professional pen tablet from Huion, that is slightly larger than the Intuos Pro Large. There is just the tiniest bit of wobble in these lines. I would also classify this as excellent. I do not notice this wobble if I'm drawing. It only becomes apparent when I'm trying to find the wobble. And again, even then, it's very, very small. This is the Wacom Cintiq Pro 27. Keep in mind, this pen display costs $3,500. In absolute terms, compared to the pen tablets I just showed you, this Cintiq clearly has some slight and noticeable wobble. In absolute terms, I would call this amount of wobble very good, but not excellent. However, if I compare it against only pen displays, then this is excellent for a pen display. I would still like it to be better in the future, but it is very good. And again, I don't think you will notice this wobble as you draw. In a few months, I'll publish another video focused on diagonal wobble. In that video, we can really go deep and explore this topic. And I will evaluate many drawing tablets to see how much wobble they have. Now let's move on to apparent inaccuracies. These inaccuracies are not caused by the EMR sensor. I call them apparent inaccuracies because these inaccuracies are visual or optical, and they come from an effect called parallax. Manufacturers of pen displays mention parallax often when they describe their products. Wacom says that their Cintiq Pro line of pen displays has virtually no parallax. We will examine this claim. First, a clear definition of parallax. Parallax is the displacement or difference in the apparent position of an object viewed along two different lines of sight. Parallax comes up a lot when we talk about astronomy, because it is used to understand how far away a star is, for example. So, it is not surprising that the Wikipedia diagram for parallax features two lines of sight that intersect on a star. At first glance, it is not obvious how this diagram is related to pen displays. But in a few minutes, you will see it perfectly describes the parallax situation in pen displays. In most of the cross-section diagrams I've shown you so far, I have not drawn the glass layer on top of the pen display. I'm talking about parallax now, so I need to add that glass layer back. For this part of the video, we will assume that the EMR sensor is perfectly accurate. So if you see a visual disagreement, it is only because of the parallax. With the glass layer, the line of sight from the eye goes through the tip of the pen, just like before, but now it travels a little bit further to touch the top of the display panel. This will affect what we see with our eyes. In this example, notice that the tablet is perfectly accurate. The red pixel is directly underneath the tip of the pen. But what your eyes will see is that the tip of the pen is touching a dark green pixel and not the red pixel. This is a clear example of how the sheet of glass will affect what you see. The parallax is not so much about the glass, but more about the distance, the separation between the tip of the pen and the display panel that is caused by the glass. And it should be clear now why I describe parallax as producing an apparent inaccuracy. Let's keep the pen exactly where it is, but change the position of the eye so that the eye is closer to the glass. This creates a new line of sight, and now in that new position, the eyes tell us something very different. It looks like the pen is touching the light green pixel, and now the red pixel is even further away from the pen. Merging these two diagrams, it's pretty clear that the position of your eyes in combination with the parallax will give you different apparent inaccuracies. Let's return to that Wikipedia diagram of parallax. Let's add a glass sheet between the star and the background. Now let's add a pen whose tip is where the center of the star is. And now we'll remove the star. And now I'll rotate the diagram 90 degrees clockwise. And now it should be clear that the Wikipedia diagram for parallax exactly matches the parallax diagrams I've been showing you. Now let's try to reduce parallax. We'll start with our original diagram of the cross-section of the pen display with a thick sheet of glass. If we reduce the thickness of the glass by half, then there is an improvement, but it's not enough. We have to get that glass really thin to make a meaningful change to the parallax. Now the glass is about 1/10 of its original size, and we have achieved a visual agreement at this position of the eyes. The tip and the pointer are at the same pixel. Let's take a look at some real-world examples of parallax. But before I show you those photos, I want to warn you, it's a little tricky to see parallax in a photograph because there's no depth information and it's kind of unclear if the tip of the pen is touching the glass or where the glass is. So for the following photos, you'll have to take my word that the inaccuracies that you see are due to parallax and not the EMR sensor. Here are 3 laminated pen displays. And again, I will explain what lamination is a little bit later in the video. The Cintiq Pro 27 is on the left. Wacom's description is virtually no parallax. I would say they have done an excellent job, so I will give them credit for that. However, I must also point out that my Apple iPad Pro has even better parallax. So there is room for some improvement. On the right, we have 2 entry-level pen displays from Huion and Wacom. You can see that there is just a little bit of separation from the tip of the pen to the pointer. Maybe they are separated by a millimeter. I would say both of these have good parallax, meaning relatively low parallax. And for entry-level tablets, I honestly am surprised how good they are. Those were 3 laminated pen displays. Now let's compare a laminated pen display against an unlaminated pen display. On the left is the Wacom 1, which is laminated, and on the right is the Wacom Cintiq 16, which is unlaminated. I told you photographing parallax can be a little tricky, but there is something special about these 2 photos which will help us. Coincidentally and accidentally, these photos were taken in such a way that you can see the reflection of the pen tip on the surface of the tablet. That makes it really easy to know where the surface is. And that helps us see how far the pointer is from the tip. The Wacom 1 on the left has a separation of tip and pointer of about 1 millimeter. But the Wacom Cintiq 16, which is unlaminated, has a noticeably greater displacement. It looks like maybe 3, maybe 4 millimeters. So that is a lot of parallax, and I don't like it, and I would not recommend buying a tablet with that kind of parallax. I've mentioned lamination a number of times in this video. Now let's talk about what lamination means in terms of accuracy. First, lamination, the word, just means that you're making a material out of multiple layers. One very good example is the laminated glass that forms the windshield of a car. The windshield is 2 layers of glass that are separated by some interlayer made of some other material. The purpose of this windshield lamination is to keep the people in the car safe. Another kind of lamination we experience commonly is the lamination of paper products. So for example, signs or restaurant menus or identification papers. In this case, the paper is in the middle and is surrounded by plastic on the sides and the edges. This lamination is done to protect the paper. Now let's get back to pen displays. An unlaminated pen display is one where there is an air gap between the glass and the display panel. This air gap has all sorts of negative consequences. Water vapor or dust can get into the air gap. Light that passes through the glass and then through the air gap can reflect and refract in weird ways that make the display less attractive. And of course, the air gap itself is creating an increased distance between the tip of the pen and the display panel. And this will mean more parallax. So unlaminated here means that the glass and the display panel are separate things. But in a laminated pen display, the air gap is removed, and the glass is bound to the display panel with another material called an optically clear adhesive. This optically clear adhesive can have a couple of benefits. First, well, it is optically clear, and that helps eliminate the light refracting and reflecting and bouncing around. And second, that optically clear adhesive layer may be thinner than the air gap it replaced, and that will of course diminish parallax. Films on top of the glass are another contributing factor to parallax. Sometimes the top of a pen display is just glass, but sometimes there's another film on top of the glass. The purpose of that film primarily is to protect the glass, and sometimes that film also provides an anti-glare treatment. But of course, that film, which is usually a layer of plastic on top of the glass, has some thickness, and that thickness will contribute to more parallax. One point I have to clarify here is that when we say a display panel is laminated, we are not referring to any plastic film on top of the glass. we are referring to removing that air gap, and only removing that air gap. This misunderstanding comes up a lot, and it's quite natural because we are so used to encountering products that are laminated by plastic. We tend to think that lamination means covered by plastic. But again, for a pen display, it just means the air gap is removed. Here are a few final thoughts about Parallax. In general, people do not like Parallax, and they would like a pen display that has as minimal parallax as possible. It is true, some people are sort of indifferent, and it doesn't bother them either way. Sometimes people find that a lot of parallax is even useful because the extra separation from the tip of the pen and the pointer helps them see what the pointer is actually pointing at. Parallax has gotten really good in modern pen displays, even for entry-level ones as we saw. So for me, I am satisfied with Parallax as it is, though of course I'd be happy if it was better. But if I had to choose, I would prefer that drawing tablet manufacturers focused on reducing lag rather than reducing parallax right now. It would be a much bigger improvement to the drawing experience. That concludes our discussion of accuracy, both real and apparent, in pen displays. Thank you for your time, and I hope you enjoyed this video.